Hey everyone, welcome to part 2 of what's going to end up being a 3-part series dealing with dust collection on this CNC. In part 1 I covered how 2 different dust boots I had on hand didn't work with the tool changer I'm setting up, and my decision to just make a custom one that works with this configuration. So anyone who has a similar need, or even if you just want to follow along on how something is taken from a few measurements to a product that you can manufacture on the CNC, might be interesting. And since this video is going to get a little long, regardless of how efficient I am in AutoCAD, I'm going to split out the actual cutting of the files and assembling and installing it into a third video to keep this one down a little bit in length. Jumping into AutoCAD, I apologize for audio quality since my desktop microphone takes keyboard and mouse noises and turns them into thunks and clunks amazingly well. So I'm just using an old gaming headset that doesn't pick up those noises quite as badly. Starting off with the 3.5-inch hole that I need for my spindle, and then the fitting I have for the dust collection to attach to the hose is 4.1, and I wanted to put an inch in between. And this is going to end up being the inside perimeter of a couple layers, and I decided I want 0.2 material before the first groove, this being a double groove design, and McMaster cart brushes that I bought needed a 0.22, and I'm going to put an eighth in between, create the second groove, and then outside of that groove I again want 0.2. And I'm going to use those to build the perimeter that will go around the spindle. Because I want to have 3 magnets, I'm going to space them, one over here, one up here, and then one that's clear of the clamp. I'm going to put this first one in here. And I need to make it a little bit bigger than a 1/4 inch, because I was a little bit shy of getting them in and I had to drill out my holes on the first one I made, which was quite a bit of a hassle. I don't want that magnet to be in the first groove here, because this one is easy to be able to help that. So I'm going to move these clear, and I do need this circle at this location, so I'm just going to offset back 0.2 again. I'm just going to connect all the layers to build these grooves in the perimeter. It looks like I forgot one of the circles when I copied. Thought I grabbed them all. I need this one over here. And mirror them, create the other side, and then trim away some of the unnecessary lines here. On this side, this is going to be my inner perimeter, and on this side, the second circle I created is going to form the inner perimeter. So what we're doing here is we're building all 3 layers on top of each other, basically, so we can see how they interact. And then we'll have all the magnet locations lined up. So this is still my dust collection hole. So right now I have what I need for the top layer, so I'm going to copy a version of this down, save that, and then the middle and lower layers are going to have a bump in around the magnet. I'm just going to freehand the line here and then mirror it, because the shape of this isn't critical. But what I need, I'm going to use a fillet command, and so I need to break this circle. And I need to break this one. Otherwise, the first time I did it, I'm going to lose the rest of the circle. And I'm going to use a 1/4 inch radius. We'll see how that looks.
Okay, that should work. So now we've got this magnet location clear of the first groove for the brushes, and then the second groove. For the other two magnets, for my own setup, I wanted them to not be inside of this inner parameter because I have tool holders in here that I need to clear going down. So I'm going to put them in the same spot here. Just using this groove, and then we'll move it up by half that groove width to center it. And I'm going to put a third one down here where I'll probably have to move it a little bit once we create the clamp. But that's no big deal. So roughly a third of the way around for each. And I copied my top layer a little bit early because I need the magnets to be in the same location. I'm just going to add them to this one. So here is our bottom layer with the brushes looking down. To create the middle layer for the spacers is going to match except for not having grooves. So we're just going to copy that down. Tighten this up just because it's going to fit on one piece of material. Okay, there's our spacer layer. There's our layer for the brushes. To the top layer, we're not going to have the grooves. And what we need to do now is we need to create the clamping mechanism here. And I'm going to do that off to the side just a little bit before I bring it in there because it's easier to work at it with a 90-degree angle here instead of at some odd angle later. Just from looking at the one I have and having created before I know them, I'm going to want about 3/4 inches of material thickness. I'm going to have an 1/8 inch gap is where we're going to do the clamping. And I'm going to build backwards here a little bit. The bolt's going to come from here and into a pocket over here. And on this side, I'm going to have a washer. And I made that much too thick for the washer, but I'll just adjust it. Pretty thin washer, actually. I just need to account for that for looking at bolt length. So I know the bolt length I used, but you would have to figure this out. Otherwise, I used a 2-inch bolt. And the length of 2 inches is from the bottom of the cap head bolt to the end of the bolt, so I need to have a pocket over here that encapsulates the end of the bolt and lets me put a square nut in there. I'm just going to start with 0.3 there, and just to give myself something to build with here to make it a little faster, I'm going to mirror that washer, and it's going to also end up representing the square nut that we need. And that's a little thicker. So around there. So we're going to have this square nut. Bolt's going to go through and the end of it's going to stick out in there. Might as well just represent the bolt here. And when we tighten this, it's going to close the gap just a little bit, and so we need to have a little bit of extra length in here available. So I'm going to make this a little bit longer than what we have. The square nut here needs a little bit of clearance to the sides of the pocket. And since I know that's a 3/8 wide nut, I can just look at it and say I think that's going to do it. And I'll mirror that to the other side. And we're going to use an 1/8 inch bit to end up clearancing this out. So I'm going to put an 1/8 radius so that matches our tool diameter. But what happens here, if I do it on this side, this square nut is no longer going to fit in there. It's going to hit the curves instead. So we need to create some clearance for that. So I'm going to use that with again, a 1/8 circle here so that we're using our 1/8 bit. I'm going to bring this over to where the square corner of the nut will still fit there. The nut's not going to be a perfect 90, so we can be tight there. And then when I get rid of the extra here, we've now created something that could be machined with our 1/8 inch bit that's going to clear the square nut. So we'll just mirror that over and clean it up. Alright, so this whole pocket can be done with the 1/8 inch bit. So we've got planning for a 2-inch bolt to come through here and clamp. That's a little off center just as far as material and looks. What we need to do now is figure out where we're going to place this. And I'm just gonna visualize where it hits here to start with. You want this gap to hit close to parallel with the edge of the circle. You don't want to be over here, let's say, because if you picture this being out, when you tighten this down, this corner is going to be headed inwards like this. And you'd like them to be coming straight together just to not put any internal forces in the acrylic. And I can just see that when I radius this, I'm going to be into the underneath the washer. So let's move this just a little bit. Working with my 1/4 inch bit that's going to do most of the work here. And we're just about perfect there. Let's get our groove all the way out. And I've gotten a little tight here on where the magnet locations is going to be. So now I can just grab all 3 layers so that they will stay stacked. And I'm just going to move this over a little bit. We'll round it up to 0.2. Should be plenty of material in there. And since this is going to be cut with an 1/8 inch bit, I think I want to leave this radius up here as an 1/8. And let's see how it looks down here. It's going to be a little funny looking because of the amount of degrees in that angle there. So just so it looks a little better, I'm going to increase this one to 1/4 and leave that one an 1/8. Just looks a little more balanced. We got our spindle, our dust collection, we've got our clamp, magnets are placed. Middle layer is just a spacer, magnets are all lined up, bottom layer has the grooves. And the last thing to think about, right now we're looking top down, so these grooves, as you're picturing the physical thing, would be on the bottom. And to machine it, we want those grooves to be up. So we're going to flip it as the last step here, so that when we put it on the CNC, we'll be cutting the grooves here. That'll end up on the bottom. For myself, for work holding, I'm going to screw the acrylic down to a piece of scrap that I can vacuum down. And I like to use the machine to mark places that are okay to put screws in when I'm doing something like that. You can use double-sided tape if you want. I've done that also. I'm just kind of a fan of doing it this way and not having to worry about things sticking down. I'm also going to mark a location, a couple of them inside of each piece that's going to cut loose. We can hold those with tabs and they won't go anywhere, but in this case that won't prevent vibration. If I just had it screwed on the outside and this gets to be almost cut loose, the material could pick up a little bit more of a harmonic there and you're going to get a little worse of an edge on the cut. So if you use double stick tape on the entire thing, you would avoid that issue also, but I might just screw down each of these pieces that's going to be cut loose, and that's going to have a damping effect on the material. I'm going to just rotate it here for the way I want it in VCarve. And we have our files ready to create toolpaths. I've got it set up now in VCarve. And I noticed a mistake I made in AutoCAD, that I had made this an 1/8 radius for an 1/8 inch bit, when of course it should be a 1/16 inch radius to match an 1/8 inch bit. And when I tried a toolpath to clean up this area with the 1/8 inch bit, it wouldn't cut the groove for some reason, even though the matching bit size, it should have run through there. And so I went back and I fixed this in AutoCAD, and I just made this 0.126 instead. So I've got my toolpaths named in the order that I want to cut them. The first thing I'm going to do is to just dimple the screw locations. And again, of course, if you're using double-sided tape or something, you can use whatever method you like. I kind of like screwing things down. It's a little just faster and easier, I think. But I do need to hold this piece of acrylic down, both while I set the corner plate on here to 0 XYZ, and I don't want it to drag a little bit and move the acrylic while it's doing these, so I'm just going to put a hand on it. The next thing is to drill out the slightly bigger than 1/4 inch. Remember, I had trouble with the magnets not fitting. And then I'd like to run the profile cut last with the 1/4 inch bit, but I also want to minimize tool changes here. So I'm going to run that before I change the bit. And we need to finish up squaring up our pocket for the nut and cut the groove with the 1/8 inch bit. And I'm going to come back to that in just a second. And then lastly, we're going to pocket for the grooves for the brushes to sit in. And always take a look and just make sure that everything's on the right side, the correct side of the line that you wanted. Everything looks okay as far as tool paths. One thing I didn't like here on this 1/8 inch profile cut, I was thinking of it more like a pocket where it would just go back and clean up the areas that weren't already cut out. But it's going to profile everything that we've already cut here. And it wouldn't hurt anything, but it's just a waste of time and inefficient. I also found that for some reason with this profile cut, I wanted to do a separate last pass, because there's a little bit of chatter with the bits that affects the surface finish. And so I'd like to do a last pass, leave like 5/1000s, and then come back and finish that. But every time I try that, I'm getting an error that the tool won't fit, even though it already wouldn't fit in here and it wasn't doing this portion of it. So if I take that off, it'll run just fine without that on there. So in a normal case, it just ignores the area that it can't cut with that bit. If I try to bump it out 5/1000s to do a final pass, it decides that now it can't fit where it already didn't fit. So what I'm going to do to solve both these problems, so I wanted to create just kind of a boundaried area here to cut with just what I wanted with the 1/8 inch bit. And I had first created a little duplicate of the area and can't find any way within VCarve to copy from, say, an endpoint to an endpoint, or to put it back exactly in place. If someone knows how to do that, none of the alignment tools in VCarve will do what I can so easily do in AutoCAD, to use endpoint, midpoint, center of a radius, anything like that, to copy from point to point. And so I've got a different solution here. We're going to copy and paste this, and then I'm going to move it a fixed amount. So we need to go relative to the current position. I'm going to move it 10 inches. I'm going to go into node editing here, and I'm going to get rid of this area and this one. I'm never confident of the snaps really within VCarve. I believe I got a straight line there, but it's just not as simple as it could be. I need to redraw the circle, and because it wants to give me the snap point for that one, let's see if I can actually get a center. Diameter 3.5. Okay. I can throw this, but it makes no difference if that's really in the middle or not. So if I do this, select both, get rid of that one. Now I've got my 3.5 inch circle back. And then I want to create a boundary around this area. So I just want to make sure that my 1/8 inch bit can fit in here. Looks a little bit questionable there. And what I want to be left with is just this area. So that's now an area that I can run with just the 1/8 inch bit. I'll close that vector. And I'm going to move it using relative again by the same 10 inches back on, and now we're lined up again. Let's go back and edit our 1/4 inch path here. And we'll try to put that last pass in. Let's preview that toolpath again. And now it's happy with the last pass. I need to go back to my 1/8 inch profile cut. And we're going to select those two. In this case, I don't have the last pass on because I don't have 5/1000ths to give. Ramped in. And I need to flip to inside. Before, when I had the full profile, I need to be outside. Alright, there we get our groove. And there's that block that I ran the 1/4 inch bit first, just so that doesn't break loose. This one will probably just kick out, but if you have a piece that cuts loose like that, it can get wedged against the wall in the bit, cause the bit to deflect, things like that. So best just to try to identify that ahead of time. And we'll just run the whole thing. You can add tabs in here if you want. I did that on the first one I cut, even though I was screwing it down, just doesn't hurt. Make sure nothing came loose. And again, I always take a look at the tool paths just to make sure everything is on the correct side. I have one dimple hole. I moved that out of the way and moved it back, but I can do that anywhere within here, so I don't need to go back and fix that. And that's all we need for it. I'll kick these out from the machine, and I'm going to put together a third video with cutting it out and assembling and just finishing everything up. Hope you enjoyed the video, and we'll see you next time.